So, very good morning to all of you, students. And today we are going to discuss slabs. Slabs in RCC structures. So, first of all, I think I should show you the images of slabs so that you should come to know that. So, these images are visible to all of you, students? Images are visible
Yes,
to all
sir.
of you?
Yes, sir.
Okay,
Yes, sir.
okay, good. See this image. See this image. Slabs, slabs are shown here. See this image. So this is slab. See this is your slab. This portion, it is slab. In earlier days, these slabs used to be rest on walls. Nowadays, we are constructing framed structures, so columns are there, and over the columns, slabs rests. So basically, there are two types of slabs. One is one-way slab and second one is two-way slabs. I shall explain you one by one-way slabs, two-way slabs. Just see this few peaks. See, this is also slab. And in that slab actually, this is the steel reinforcement. So steel reinforcement, see this, is it visible?
Yes, sir.
Yes.
Yes, this is the section, this is the slab, here is the steel reinforcement. If you will see this, these are the slab panels. These are the slab panels. And see, this is beam. I shall show you here. See this. This is your beam, right? This is your beam. These are the columns. Now, concreting has not been done. This is slab panel. These are the, for electric connections, these are the PVC pipes. So, this type of reinforcement which you are observing here, this is slab reinforcement. So, today we shall discuss related to the slabs. So, see here in my presentation also, it is quite visible that this is the reinforcement, and if you can see, this is, see here, these are, see, bent up bars, right? So these bars are bent up like this. The purpose behind this is, when you bend the bar, this portion, this straight portion, helps to take tensile forces at the bottom, and this portion helps to take the tensile forces at the top. So if we are bending these bars like this, then this is helpful to resist the tensile forces at the top. And this bar is totally straight bar. So this is a setup of reinforcement with alternate bent up bars. One bar is straight, another one is bent up. One bar is straight, one bar is bent up, like this. So in this way we provide reinforcements in slabs. Now there are two types of slabs. There are number of types of slabs, flat slabs, but here we are going to discuss one-way slab and two-way slabs. Slabs actually can be defined as the flat surfaces which are provided in building floors, roofs and bridges. First of all, the formwork is erected. Over those formworks, the reinforcement is provided, cage is provided, and after that casting is done. So let us start with what exactly one-way slab is. So again, I will show you few images especially for one-way slabs. One-way slab images, please see. Is this image visible? Is this image visible, sir? Yeah.
Yes, sir, visible.
So see here, in one-way slab, the steel reinforcement straight bars are provided along the shorter span. So this is your main reinforcement. See this image. In this image also, you can
Grammarly can help you write quickly.
You can see this. Here the main reinforcement is laid down along the shorter span. So in one-way slab, you see this figure, this image. These main bars or main reinforcements are along the shorter span. And perpendicular to these main reinforcement, distribution bars, we call it as, these are provided. So in one-way slab, main reinforcement is provided along only one direction. Now, see the images of two-way slabs. See this image. Here, this is your shorter span and this is your longer span. In this, main reinforcement is provided along the shorter span also and along the longer span also. So in both the spans we are providing main reinforcements. We are providing these alternate bent up bars both the spans. So this is the difference between one-way slab and two-way slab. This is the actual reinforcement. You please see here. You will find that the main reinforcement is provided in both the spans. But as compared to two-way slabs, in one-way slab, distribution reinforcement is provided along the longer span and main reinforcement is provided along the shorter span. This is the difference. Now the question arises, when we have to take one-way slab and when we have to design two-way slabs. Now that we shall discuss here. In one-way slab, if you are getting longer span ratio, longer span to shorter span greater than 2, you go for one-way slab. Generally, I have mentioned here the examples as in case of cantilever slabs, chhajjas, balconies sometimes, many a times we design one-way slabs. When your ratio, this ratio is also known as aspect ratio. So this ratio of longer to shorter span is greater than 2, you have to design one-way slab. See here, suppose you assume that your longer span is 8 meters, shorter span is 3 meters, so it is 2.66, which is greater than 2. So you have to design this for one-way slab. One-way slab means main reinforcement to be provided along the shorter span. So here the shorter span is 3 meters, so this is your reinforcement, and this is the longer span, so distribution reinforcement is to be provided. If we talk about two-way slabs, the ratio is same, longer span to shorter span. If your ratio is less than 2, you have to design two-way slabs. Generally, these two-way slabs are to be designed when construction of multi-storied buildings takes place. So see this, here 5 by 5, both the spans are same. If suppose 6 by 5, it would have been the dimensions of the slab, and one dimension shorter span, another one longer span. Still in two-way slabs we provide main reinforcement in both the directions. When load exceeds, when we will discuss how to design the slabs, you will come to know. When load exceeds, these two-way slabs are to be designed. Now this is the general idea about one-way and two-way slabs. Now let us see what is the difference between one-way and two-way slab. Important question for interviews. In one-way slab, shorter span we provide the reinforcement and your slab is rested in most of the cases on the beams or walls on two opposite sides. On the contrary, these two-way slabs are supported either by walls or beams on all the four sides. I have already discussed main reinforcement is provided along the shorter span in one-way slab, in two-way slab in both the directions we are providing the reinforcement. The same point I have elaborated here, that main reinforcement, it is not like that in one-way slab we are not providing the reinforcement along the longer span. No, we are providing. But distribution reinforcement we are providing. Main reinforcement has to be provided along the shorter span only in one-way slab. In two-way slab in both the directions we are providing. Now, load distribution. When slab is acted upon by the load intensity, loads are carried along one direction in one-way slab. But the load distribution in IS 456 it is given. It is somewhat trapezoidal in shape, and loads are distributed, carried along both the directions in two-way slabs. Now, in practice, generally, this ratio, aspect ratio, is not considered. Means importance to this aspect ratio is not been given. Designers never give that much importance to this ratio. Generally, when drawing comes and when structural planning is done, beams and slab panels are decided S1, S2, S3 like this. Then looking at those panels, designer designs S1, S2, S3 like this. And generally when dimensions are near about same, loading is heavy, then on two-way slabs we design. And in practice generally we try to accommodate all panels in 5 categories or 3 categories: S1, S2, S3, S4, S5. So in practice it is different, but in academics it's okay that we design one-way slab when the ratio is greater than 2, we design two-way slab when the ratio is less than 1. Like this it's okay for academic purpose. But in practice we are designing, a designer used to design the slabs looking at the slab panels. So students, this is the brief introduction about the slabs, one-way slabs and two-way slabs. So I think you might have enjoyed this lecture, students. Thank you very much. Thank you.